Now, in the last video, I showed you how to make two orthogonal or right-angle components of a vector A. This video here is going to be short, but I'm going to show you how to do an example calculation of that, then leave you with 4 problems to try, and then give you the answer to those problems to see if you're doing it right or wrong. Okay? Now remember, given A, we can create a horizontal and a vertical component by taking the length of A, the value of A vector, multiplying it by cosine theta to get the horizontal component, taking the length of A, the value of A, and multiplying it by the sine theta to get the vertical component of that vector. So let's make use of that and let's try a problem. So what I'm going to do is give you a vector. And the value of that vector will be 46 newtons. I'll give you the angle will be 35 degrees north of east, and I want you to find the horizontal and vertical components of this vector. So let's put them in. First, the horizontal component, which would be a vector like that, followed by the vertical component, which would be a vector like that. Okay, let's deal with the horizontal component right in here. The horizontal component x will equal the original vector A, which will be 46 newtons, and we're going to multiply that by the cosine of 35 degrees. Adjacent to the hypotenuse, so we use cosine. Pull your calculator out, do the arithmetic. I believe you come up with 37.6 newtons in the x direction. Sometimes it helps to put a little arrow like that, which tells you that this vector is going in that direction x. There's actually 2 directions, x, left and right. This will tell you which way it's going. Do the same thing for the other vector. Vector y, the vertical component, will equal the 46 newtons, the hypotenuse, and we're going to multiply this by the sine of the angle 35 degrees. And once again, if you do the arithmetic, put that in your calculator, you should come up with 26.4 newtons. And once again, tell you the direction of that vector, that the vector is going straight up and down. Remember, these are the orthogonal components of this particular vector onto here. Okay, now, so what I'm going to do, if you get that, I'm going to give you 4 problems. Try these. Pause the video. Try them. Then look at the video again for the answers. Alright, so here's the first one. Now try these. Remember, I want you to find the orthogonal components of each of these vectors that I give you. They're all going to be colored red to start off with. I tend to use red as the resultant vector just to, you know. First one will look like this. Alright, now this is A, and this vector here will be 600 meters, and the angle will be 15 degrees. Second one, vector that goes like this, and that vector have a 5 meters per second, and the angle right in there will be 20 degrees. The third one, C, will be a vector that looks like this. It'll have a value of 52 newtons at an angle of 42 degrees north of west. And the last one, D, will look like this. It'll have a value of 1.7 meters per second at an angle of 25 degrees. Now at this stage, pause the video, try the problems, and when you come back, the answers will be given to you. So pause the video now. Okay, now that you've unpaused the video and done the answers, I filled all the answers in. Check your answers off. There's a vertical component of A, horizontal component of A, vertical component of B, notice the directions downwards, horizontal component of A that way, vertical component of C upwards, vertical component of X towards the left, vertical component of X up here towards the left, vertical component of Y for D, and that's going downwards in there. Alright. Now, this is a very important part of this vector situation. You'll see why coming up in a little bit, but you must be able to do this. You must be able to take any one vector and split it up into orthogonal components. And you must be able to take two orthogonal components, like this x and that y, add them together, get the resultant vector. Those two are absolutely crucial to understanding how vectors go on. Alright, now while I've got you here, I'm going to move on, and we're going to do vector equations. What does it mean when you add and subtract vectors? Now, let's take a look at this and see it. Let's do one simple example, the different, and then one a little more complex example on it. Let's suppose that I have two vectors, and I'm going to both make them the same vectors so we can see them. Vector A, call it vector A, call this vector B, and then I'm going to give you an equation that says, what does vector A plus vector B equal? And we'll call that vector C. All right. Well, you know from our previous discussions that vector A plus vector B added together in a linear fashion will give you a resultant vector like that. Okay? But that's what the equation said here. But hold on a second. What if I just changed the equation a little bit? What if I said I want you to take vector A, but I don't want you to add it. I want you to subtract vector B from vector A, and I'm going to get vector D that way if I do it. What does that actually mean? What does A minus B vector actually means? Well, mathematically, if you remember, vector A plus negative B is another way of saying A minus B. Adding the opposite is the same as subtracting it. Remember that? Okay, so what does this negative B vector? What is this negative B vector right there? Okay, let's go back to doing this. Well, if I take vector A again, it doesn't change. Vector A will be the same vector that we drew before to the same length we have it. That doesn't change one little bit. But what does vector negative B mean? The same vector B? No, it's not the same. Same magnitude, but there's one thing different about it. The one thing different about it is that it changes direction. That now is negative vector B. And now I hope you can see that the resulting vector now is not the same as before. Here is the resulting vector D right in there. So adding vectors and subtracting vectors are not the same thing. Hope you can get that. Okay. Now let me try another example with you. Let's take two more vectors. I'm going to call them A and B again for the sake of it. Let's go like this. Wrong color. Let's go back to blue. And because I have no imagination, we're going to call this vector A. Change my color. And we're going to call this vector B. Okay? There are two vectors that I want you to do. All right. Let's move into the center. Okay, we'll look at those permanently, and we're going to make two equations. The first equation right over here is going to say take vector A and add vector B to give me, vector C into here. The second expression is going to take vector A, subtract vector B to give me a resultant vector that's going to be called, I don't know, let's call it F just to be different onto here. Okay? Alright, so here we go. Take the first vector, which is vector A. And we're going to put it 1 here. There's vector A. And I'm going to do exactly the same thing here. There's no difference between these two vectors. Both are vector A, and there they are right there. Drawing vector A, label them. Vector A, label them, vector A. Now, this one says add vector B. Okay, change colors. There's vector B. Vector B will go up just a little bit, and it's going to go up like this. And we need a little more thicker than that, I think. So you can see it. There it is. And that means that the resulting vector must be vector C here. That's the resultant vector right there. Okay? Now what about this guy? Well, now remember, we're not going to be adding vector, we're going to be subtracting it. We'll have to take vector A the way it is, add the negative vector B, and if we do that, we will get this new vector that we call F. Now remember what it is. Negative B vector is the same magnitude B but going the other direction. So we're going to have vector B go like this. And that is labeled as negative B vector. The resulting vector then will be from here, starting point, to the end point there, and that is going to be vector F. Now it'll have the same magnitude as vector C, but it'll be in a totally different direction, and that means there'll be different vectors that are on there. Okay? I'll give you one more example to try. Pause the video, then watch for the answer afterwards. So here you go. Now try this. Now try this. Give you two vectors. First one will be a vector like this. And we're going to call this vector, I don't know, W. And then we're going to have a second vector, and I'm going to go like this. And I'm going to call this vector Y. Alright, two equations then. I want you to take W vector plus Y vector to come up with vector Z. And then after you've done that, I want you to take W vector, subtract vector Y, and that means you're going to come up with a brand new vector, and we're going to call this vector U because we got to call it something different than Y. Pause the video and then look up your answers. If you're watching this video at this point, then you have unpaused it. There's your answers. I hope you can see that vector Z is not the same as vector U. You now know how to deal with adding and subtracting vectors. Next up, adding vectors by component method.